So hello, my name is OT. Welcome to Steady Bro, and I'm your bro for life. So we'll be looking at the stage 2 of glycolysis, right? We looked at the first stage in the previous videos, which was the conversion of glucose to GAP. Now, in stage 2, we'll be looking at the conversion of GAP to pyruvate. From GAP, we produce 1,3-bisphosphoglycerate, catalyzed by glycerate 3-phosphate dehydrogenase. Now, this reaction is interesting as it allows the production of our first ATP. Not directly, just remember that we've trapped a phosphoryl group in the 1,3-bisphosphoglycerate. Because we've trapped a phosphoryl group in the 1,3-bisphosphoglycerate, we can now bring an ADP, adenosine diphosphate, means adenosine with 2 phosphate groups. We are trying to produce adenosine triphosphate as an adenosine with 3 phosphates. Now we bring ADP, we will produce 3-phosphoglycerate plus ATP. This making sense? Okay, let's look at this again. We had our GAP. We are trying to produce ATP. We add an orthophosphate, a single phosphoryl group, catalyzed by glycerate 3-phosphate dehydrogenase, forms 1,3-bisphosphoglycerate. So in this 1,3-bisphosphoglycerate, we've trapped a phosphoryl group. In the next stage, we take our 1,3-bisphosphoglycerate, we add adenosine diphosphate. We do the reaction, which is catalyzed by phosphoglycerate kinase. We produce 3-phosphoglycerate plus ATP. And voila, we have our first ATP molecule. To move on to produce our second ATP molecule, 3-phosphoglycerate is converted to 2-phosphoglycerate. This is done by phosphoglycerate mutase, moving the phosphoryl group on 3-phosphoglycerate in a different position to form 2-phosphoglycerate. Basically moving the phosphoryl group from the 3rd carbon to the 2nd carbon. From 2-phosphoglycerates, a dehydration reaction occurs which converts it into phosphoenolpyruvate. Now this reaction is catalyzed by enolase. From phosphoenolpyruvate through pyruvate kinase, we are able to produce pyruvate and ATP, our second molecule of ATP in anaerobic glycolysis. The conversion from phosphoenolpyruvate to pyruvate is practically irreversible. It allows glycolysis to be regulated. Thank you for watching. I appreciate it. And salutes! But before I go, let's summarize glycolysis so far. So we know glucose plus ATP gave us glucose 6-phosphate and ADP. Then glucose 6-phosphate was converted into fructose 6-phosphate. Fructose 6-phosphate plus ATP gave us fructose 1,6-bisphosphate and ADP. Remember, this was catalyzed by phosphofructokinase, a key enzyme in the regulation of glycolysis. Fructose 1,6-bisphosphate was cleaved to give us GAP and DHAP. GAP was subsequently converted into 1,3-bisphosphoglycerate. 1,3-bisphosphoglycerate plus ADP gave us 3-phosphoglycerate plus ATP, our first ATP molecule in glycolysis. 3-phosphoglycerate was mutated into 2-phosphoglycerate. Through the activity of enolase, 2-phosphoglycerate was converted into phosphatenolpyruvate. Then finally, phosphoenolpyruvate plus ADP gave us pyruvate plus ATP, our second ATP molecule. This concludes anaerobic glycolysis. In the next video, we'll be looking at how glycolysis is tightly regulated by the enzymes I made mention of. Thank you.